So we have MathWorks. Ellen Johnson will present us, I think, a much awaited version of HDF5.
Right. Can you guys see my screen?
Yes.
Okay. So I won't have pretty pictures like Danny had, but yes, it is a long awaited update for MATLAB and HDF5. So thank you, everyone. So let's get started. So I'm a senior software engineer at MathWorks. I am in the team that handles the interfaces, customer interfaces for audio, video, image, and scientific data formats. So I went a little fast there. So today I'm going to talk about the overview of what we've done in the past couple of years and adding of SWMR and VDS. I'll go into the functional details there. I have a quick demo that I hope will work, showing VDS with SWMR with MATLAB parallel pools. I want to give a special shout out for performance and then compatibility considerations, because there is a Linux compatibility issue I need to discuss. I'll talk about future work, and then we'll wrap up. So the topics covered today are available now in the 21B pre-release. The official full release is not out until September, but MATLAB users do have, can use the pre-release now, and we would love you guys to use it and give us feedback. Okay, so what have we done? So yay, MATLAB 21B, again, pre-release, official release September, is now using MATLAB. Our customer-facing interface is now for HDF5 is now using 1.10.7. We've added new functions in our low-level interface for SWMR, Virtual Dataset, some for fine-tuning metadata cache, and partial edge chunk. We also, of course, modified several of our existing functions to work with 1.10.7. Now, you might ask, well, what was the delay? Well, the delay is that we're not the only team at MathWorks that uses HDF5. There are other teams that use it internally, most notably MatFile version 7.3 are based on HDF5. We use the same, well, we used to use the same library for HDF5 under the hood, 1.8.12. What we had to do as an interim solution, well, the problem was that math files have a very specific use case. They're using HDF5 files in a specific way that results in lots and lots and lots of really tiny data sets. And that's not, we have heard that from customers, from our customers, but it wasn't so much what we've been hearing. Mostly we're working with folks that have huge n-dimensional data sets. So when we tried to upgrade to HDF5 1.10.2, a couple of years ago, we saw huge regressions in MatFile 7.3, and that was just unacceptable. We can't do that for our users. So we had to figure out an interim solution. And we consulted with the HDF group, so thank you for that. And we're talking to the other MathWorks teams. But our interim solution is that we're shipping binaries for both 1.10.7 and 1.8.12. Our customer-facing interface uses 1.10.7, 1.8.12. MatFile folks and the other internal teams that use HDF5 are on that. We had to do a lot of magic with symbol versioning. We learned all about flat namespaces in Linux versus two-level namespaces in Mac OS and Windows, but we got it to work. Our goal is to ship one version. So the shipping two binaries is an interim solution. And also our goal is, now that we're current with 1.10, we want to stay current with the upcoming releases. So for the functional details, MATLAB, hopefully you guys know that we have two interfaces. So our high-level interface is ease of use, but it does have less control. Our low-level interface wraps the C library pretty directly. A lot more control. There's over 300 functions that we have. So for SWMR and VDS, and for the other new support for the new features, we added about 30 new functions to our low-level interface across the 16 APIs. Now, with that note, we did not add direct control of creating virtual data sets and starting up SWMR from our high-level interface, but our high-level function H5 read can read virtual data sets, so we confirm that. So that is a nicety that we got from that. There's also a note that, because there was another presentation that talked earlier, somebody asked about the HDF5 VFD with VDS. There's a lot of acronyms, and the cloud locations. So a couple of years ago, we implemented our own VFD. So since B, I believe, we've support our HDF5 interfaces. All our functions will work with data hosted on the cloud on S3 Azure, and I believe read only for HDFS. VDS, we tested, works with this, which is a real nicety that we got, but SWMR won't because of the POSIX requirement that was discussed earlier. Okay, this is, I know there's a lot of information here, so I don't expect you to read it all, but this just shows the HDF5 1.10 new feature and what the equivalent MATLAB function, which is really very close to the C API, what we've done. So VDS has the most new functions. SWMR, of course, the big ones for that. And we did consult with the HDF group about the other new functionality in 1.10 for other stuff, other functions for fine-tuning metadata cache, for page buffering and file space management. And this is what we decided on to ship for this release. We'll take a watch and wait feedback to hear from customers for adding more. So this is the demo that hopefully will work. So let me just go over, this was made by our awesome advanced support engineer that supports our team, who has a physics background and modeling background. And what he did was he is showing SWMR with VDS and with MATLAB parallel pools. So what this is going to show is there's 3 source data sets, disjoint, and we have the destination virtual data set. We're running, so each of the, so there's 4 instances of MATLAB, 3 for the source files, 1 for the virtual data set. He modeled a scenario in which there's ocean buoys collecting data, and about what it would be for he called a meteorite, but like the wave propagation from a rock or meteorite in the waves. So what we have is single writer for each of the MATLAB processes that are the writers, and they are running in parallel via PowerPool, and he launched that in the background. Each of them have 2 readers, one to display the virtual data set information over here, and one to display the source data set as the new information is getting updated using SWMR. So I'm going to start this. It's a quick movie, and it takes a minute to fire up because the data is all loading. But then it's going to show, yay. So here's the disjoint data sets, the source ones, and it's SWMR is constantly updating data. The VDS is refreshing the data. And what's nice over here is it really shows, so also he created this disjoint space, so that's fill values, and you can see that it's really, the model is really nicely, there's no seams or anything. It's very, very smooth about putting together those data sets and running SWMR and VDS together. So that was really cool. Big thanks to Cedric for that. Okay, so let's go on. So I'll talk about performance. So this is performance specifically for our customer-facing HDF5 functions. This is not the performance that I talked about earlier related to MAT file 7.3, but they're related. So we did see improvements across the board for moderate improvements for H5 write, H5 create, and many of the low-level functions. Some for H5 read. It really depends on the workflow. The regressions, now this is something that we're investigating. If there are files with huge amounts of heavily nested groups, especially if those groups create have small data sets in them, we saw pretty substantial regressions in H5 info. So we're working with the HDF group to determine the root cause on that. If it's the same issue underlying as with the MAT file version 7.3 issue that we saw when we tried to upgrade to 1.10 for that. So the future performance work, we know we have room to optimize our C++ HDF5 code base. We've already identified target areas for that. And we're going to be definitely adding more real-life workflow-based performance tests instead of a lot of ours are just testing, not real-life situations. So that really will help us measure performance from release to release now. So compatibility, here's where I'm going to talk about the Linux-only issue with filter plugins. So we will document this, and we have options for this. But because we're shipping 2 binaries, and because in Linux only we had to symbol version both versions of the binaries, 1.8.12 and 1.10.7. The filter plugins will need to, if they have calls to the core HDF5 library outside of H5PL extern, they need to rebuild with our symbol versioned HDF5 1.10.7. Otherwise, there'll be symbol conflicts, unexpected behavior all the way down to crashes. Not good. So we have one option where folks can rebuild their plugin with our shipping binary of 1.10.7, which people can see from when, with MATLAB, and the headers that they'll get for 1.10.7 separately, because we don't ship the headers. Option 2 is we will publish our actual GNU export map, which we use to create the symbol versioning. And then they can grab that export map, build their own local 1.10.7 with that, and then rebuild their filter plugin with that. Again, we'll provide documentations, and again, interim solution until we ship one version, which is a really big goal for us. Another compatibility is, of course, hopefully everyone knows with H5P set lib verbounds, and if it's latest and latest, which now latest is 1.10 for us, it will create incompatible files with earlier versions of MATLAB that are still on 1.8 and the highest is in 1.10. So I think that's a known issue. The HDF group documents about the incompatibility between the versions. I believe I'm not a huge user of H5 Repack. I know there are tools I think that can help with this. So just reach out to us for any questions. Okay, so future work, our highest priority, again, one version of HDF5, the Linux filter plugin workaround won't be needed. We do want to add, we've supported reading data sets that have been compressed using DLFs. I call them DLFs, dynamically loaded filters, since 15A. We want to add, of course, writing data sets, also direct chunk read and write. We want to add high level support for controlling SWMR and VDS, and upgrade to HDF5 1.14 when available, and evaluate the new features that have come along since 1.10.7 on the new branches. And we're going to take a watch and wait approach for other features, for 1.10 features. Again, support for the greater than or equal to 1.12 new features, the vol connectors, and we're looking for community feedback. So with that, just the summary is, yay, MATLAB now current with our 1.10 branch, HDF5 1.10 branch, added SWMR VDS capabilities. There's the Linux plugin compatibility issue. Talk to us for questions. Please try out our new functions in 21B pre-release. We love feedback. It really helps improve our products. And please reach out to us, not, for wish lists as well, not just questions. There's my email. I'll post it in the chat. And with that, that's my talk. Thank you so much. Any questions?
Thank you, Ellen. Yeah, excellent timing as well, but very interesting, especially that now our users who like MATLAB will be able to get this, use VDS, yeah.
Right, awesome. So if there's any other questions, let me know. I'm just trying to figure out how to unshare my screen. Hold on, because we don't use Zoom at work, we use Teams. Okay, got it.
There's a question, there's from Herb. Is it okay to use 1.12 in 1.10 compatibility mode with MATLAB, or do we have to use real 1.10?
I'm not sure I understand that question.
We're in the conversion from 1.8 and 1.10 to 1.12. In order to keep from blowing up everything we've got, we use 1.12 as if it were 1.10 as a compatibility mode.
Okay.
So this is the files being written in a way that HDF5 thinks they look like 1.10.
Okay.
Okay. Is it okay to try that, or should we just be using a real 1.10?
So really quickly, the setting that you're using, that's the HDF5 setting itself. That's through the HDF core library.
That's their compatibility, where they think they're making 1.12 look like 1.10.
I see. I think it should work. I don't know the answer to that, and I can do some testing for you and talk to Elena and the HDF folks.
Please.
And I'll get back to you.
Thank you very much.
Thank you. Yes, Mike Folk, you can.
And there was a question from Alice if the some code for the S3 or Azure would be shared, or
our internal VFD that we wrote that lets us do that. No, that's internal. Well, That's internal only. Who asked that question?
SL, I forget, LS, sorry, LS.
Okay, all right. So yeah, we normally wouldn't share internal code, but I can check with my management here to see if we can do that in a special case. Elena had also asked us about how we were able to do that. So let me work on that.
Yeah, I think, I mean, we will definitely also at ESRF encourage our sysadmins to install the pre-release so that our scientists can try it.
Thank you.
I think at the moment they are doubling the disk space by converting to older formats. There was a question. Question is more if we could enable the HDF5 library to write data stored in S3 and Azure.
Oh, a question for then the HDF.
That's for HDF group.
Okay.
Right now, we have only S3 read-only virtual file driver, but you can do it through HSDS and RESTful, which has some limitations.
Okay. But no, very good news. Well, so no other questions. Thank you very much, Ellen, and thank you for this good news.